Alright, so anyways, note folks, on the first test, or the next test, this is the first question. It's an exact copy of the way the first question is going to look. I'm going to have 5 rows. There's going to be 3 columns, fraction, decimal, or percent, decimal, fraction. I will put one number in each row. You have to put the other 2. So, very first question on the next test, you now have a sample of it right here. Alright? Not bad? Alright, so how about the word problems? How do I do 180 is 120% of what? Who hasn't gone yet and is feeling it?
I'll go.
Okay, Jeremy, help me out.
You'll do the is over of equals percent over 100.
Okay, so is over of equals percent over 100. Where do I put what?
180 is before is, so that goes before the is.
Okay.
And then the 55 goes for.
Whoa, we're doing the one above it. Hang on.
Oh, wait, sorry.
Sorry.
So x goes under that because you don't know what you're on it.
Yep.
And then 120 is percent over 100.
Perfect. And what do I do to solve that?
Cross, multiply, and divide.
So what do I multiply and what do I divide?
180 times 100 divided by 120 percent.
And what did that work out to be?
150.
Bingo. Nice. Okay? Folks, I like percentages that are really, really big or really, really small on the test. So I will often have a question that says, what is, 1,500% of 72 or something like that, right? Again, just make sure that you understand the basic concepts with percentages that aren't necessarily between 0 and 100. All right. How about the 81 is what percent of 55? Caleb, you're on this one?
Sure. So you put 81 over 55.
Now, why is the 81 over the 55?
Because 81 came before it is.
81 came before the is, yep.
Yep. 55 is.
The of.
Yeah, yes, right. And then equals x over 100.
X over 100 because we don't know what the percent is. So what do I do?
Cross multiply.
Cross multiply. What do I multiply?
81 over, or 81 times 100 and 55 times x.
Or 55 times x, yeah. And then what am I going to do in order to get x by itself?
The stats of 8100 or 55x equals 8100. And divide by 55 is 147.27.
147.27, and technically what's the number after it? It's repeating 27. So it was a 2.
Round to the 100.
Round to the 100th, so since the number next to it was a 2, you round the 7 to a 7, keep it the same. Since it's a percent, put the percent sign after. Okay. If you would, please, when you are asked to create a percentage, it would be nice if you put the percent sign after your number. Technically, if you don't put the percent sign after your number when it's a percent, it's actually wrong. I tend not to be overly picky about that because I'll ask questions like, up here, what percent is this? And so you say, oh, well, it's 147.27, and since the question asks for percent, it implies it's a percent. Working off an implication, folks, is really scary. So please put the percent sign after numbers that are percentages, okay? If it's not a percent, don't put a percent sign after it. It's actually wrong if you put the percent sign after a number when it is not a percentage, because that means that you're dividing the number by 100, and that's, not what you meant to do. Okay, so just be careful with the percent sign. I had a student one semester who figured that since we're on the percentage section, what they did was after every answer, they wrote a percent sign. Because this was the percentage section, so everything must have been a percent. Even when it was money, they wrote a percent sign and dollar signs. And I was like, what the? No, I had to mark points off, okay? Because that's not correct, right? Only put a percent when it is a percent, all right? So, not bad with our one sentence percentages. Oh, I love this question, folks.
Why do you have so much space?
Because I gave myself more space. In order to make it fit on the page, I had to take your space away, and then I get back in here and give myself space so I have room. Well, I wanted to fit on one page so I don't waste paper. I get yelled at when I waste paper. Come on, I'm trying to save you guys money. If I print up a whole bunch of paper, they're going to start raising your tuition even more than they already do. So
Let's not print these off and just scroll down.
in theory, yeah. Huh? All right, so who feels up to this one? This one's a little tricky. All right, Abby, you want to guide me?
Yeah.
Okay.
I set it up as 2,000 over X equals 20 over 100.
Whoa, wait a second.
It's because you owe 80%, which means you've already paid 20%.
Okay, there's the great interpretation on this problem. Is that if you owe 20%, folks, what did you put? If you owe 80%, what did you put down? 20%. That's the complement, right? You know if you're owing 80%, you have to put the 20% down. And this $2,000, is it talking about how much you owe? Yeah, but what do we, that's about how much we want to put down versus how much we owe. So this is what we have to work our numbers with, right? The $2,000 equals the amount of money down, and therefore these two numbers are related. All right? So the key is sort of working off the fact that this label and this label are different. Therefore, those percentages do not work together. Okay? Percentages will only be tied when you're working with things that have the same label. And so you have to tell me that if they owe 80%, that they put 20% down, and then put that with the 20% as a portion equals base times rate problem. Or is over of, as the case may be. And so then what did you do to get x?
X equals 2,000 times 100 over 20.
And nicely enough, what does that work out to be? $10,000. And if you think about it, folks, if you put $2,000 down, that's going to represent 20% of 10,000, hence you owe 80% left. All right? And if you try and get to this answer by doing addition, almost never going to succeed. Okay? So the classic student mistake is to say, well, take 80% of 2,000 and then add it. Or maybe take 2,000, divide by 80% and add that one instead. And you will never get to the number, ever. You will never get far enough to make 10,000. All right? The key is that this particular problem is a straight percentage problem, not a percentage increase or decrease, so there's no adding or subtracting that goes on. Okay?
I mean, unless you see that 80% is just 8/10 of a whole that you're finding,
Mhm.
add 2,000 because it's 1/5 of the total, so you just times it by 5.
Right. Exactly. You multiplied by 5. You didn't do any adding. You figured out the complement of 80%, or 8/10.
You could add it 5 times, I guess, really multiplying. But
True. If you want to do addition instead of multiplication, yes, that works. All right, but again, I do like questions like this. And again, this one's a nice one because the numbers are really easy. But please realize the numbers could be less than pleasant, right? All right. All right, how about this next one? All right.
So I took 7,500 minus 2,300
Okay, now you're going to have to explain to me why you're doing this.
because it's out of 7,500 students, and 2,300 said that they watch more than 1 hour of TV per night. So the remaining would be the ones that do not watch more than 1 hour.
All right, good. 5,200 do not watch more than an hour of TV. So here's an alternative to doing that complement with the percentages, and that's to set the complement up at the start. If you know that 2,300 people said that they watch more than an hour of TV, the rest of them, the complement of that given your actual numbers, is the number that do not watch that. So you can subtract first, sort of as opposed to last. Whereas in this problem, Evan was saying, I know how to get from 80% to 20%. Worked with the percentages. It also works with the numbers. Okay, so now where did you go from there?
So I did 5,200 over 7,500. And I basically just divided them, and I got 0.69333333. And then you have to move the decimal spot 2 places to the right because it's a percentage.
Mm-hmm.
So it's 69.38%.
69.3 repeating. What did the problem ask us to do, though? Round to the nearest hundredth of a percent, so how would you write it?
69.37.
Exactly. And note, folks, you could have perfectly done this problem with the number 2,300. You could have used 2,300 over 7,500. You would have gotten a percentage. But then you would have the percentage of the people that do watch more than an hour of TV. All you have to do is take 100% minus that to get you to the 69.33. All right? Either way, perfectly okay. All right? Doing it first, great idea. Because then you can at least know, okay, I'm working with the numbers that I know are connected. And this is a very classic sort of thing to do, folks. There's at least 3 or 4 homework problems that do the exact same thing. Okay, so do not be fooled by the book doing similar stuff. And I'll do it on the test too, so you may as well get ready. Alright? Not bad? Alright, so now on to the fun stuff. Compact computer is advertised. Did they still make compact computers? I wrote this question like 5 years ago, and I've just been changing the numbers, every other year or so. So I honestly don't even know if they still exist. Has anyone ever actually looked in the last? I know they don't make laptops, so it's like, meh. There's a good chance these are gone. But anyways, an older computer is advertised at $1,800. This is 18% less than the original price. What was the original price? All right, so one of the things I would like you guys to do when you tackle these problems is at the very beginning, tell me what kind of a problem it is. Is it a straight percentage problem? Is it a percentage increase problem? Or is it a percentage decrease problem? For this one, which one is it? Why is it decrease?
It says 80% less than.
Yeah, this is a percent decrease problem. Now, what do we never do in a percent decrease problem? Yeah. Now, when you read that problem, what kind of a number are you looking for, though? Compared to 1,800. You want something bigger, right? Because it's been discounted down to this $1,800, okay? Do not let the comparison of the number trick you into thinking that this is a percentage increase problem, okay? That is the classic mistake that students make. They'll say, oh, this is a percentage increase. I need to get a bigger number. Take 18% of 1,800 and add. Nope. That never works, okay? So, again, what I like to do, just because I like to practice algebra, and it never hurts to practice it anyways, is to say, oh, okay, this is new equals old minus rate times old. And what did I give you in this problem? New and rate, right? New is the $1,800. The rate is 18%. And again, write it as its decimal. And so old is going to be X. I gave myself more room, but not enough. And now you can just throw those things in there, right? So, go away. 1,800 equals X minus 0.18X. What is X minus 0.18X? Okay, good. So 1,800 equals 0.82X. Remember that we don't write it, but it's there. 1 minus 0.18. Again, decimal points, be careful with them. And so last but not least, what do I do to figure out what X is? Divide by the 0.82. And this is how you get a bigger number, folks. You divide by a number that's less than 1, and your number will go higher instead of lower. Right? So somebody on their calculator, if you wouldn't mind, 1,800 divided by 0.82.
It's 2,195.
Any pennies?
Yeah. Well, I rounded to 12. It's money, so 1, 2.
1, 2, yeah. And yes, it's money, so you know, round it to pennies.
I looked on Best Buy and they only sell refurbished.
Oh, but they do sell them though? Okay, good, they're still there. Good. I didn't leave this question in there though.
When you say compact computer, are you talking about a computer that literally has a power and a monitor in it? Because that's what I found in some old ones. Like, literally it looks like a box, and then it's like down the screen.
The high schools use them still.
Oh,
It's just the computer, not the monitor.
not the monitor? Okay, cool. So it's still a relevant question. I can leave it in there.
They make just the computer thing, but not a monitor inside of it.
Right, yeah. Not the new style ones where the hardware is inside the monitor, yeah.
That's different.
Yeah, it's old school. I'm okay with old school, as long as they're still selling it. All right, so again, folks, a great problem. It's also one of those ones where as long as you're careful and you read the 18% less right off the bat, you should be safe. All right. Now, how about the Macy's Day Parade one? Yeah. Nope. 9% increase. This is a percent increase problem. How do we do percent increase problems? New equals old plus rate times old. Now, what did I give you this time?
Old and rate.
Old and rate. Why is the 450,000 old and not new?
Because the 9% is going to be an increase over
You gave the number last year and said they wanted increases.
Yeah, they gave you the number last year and they want to know what's it going to be this year. The cool thing about time is that you can kind of tell. If it's last year, that means it's old, and this year is going to be new. So this one, you get to say, oh great, old is just the 450,000. Rate is the 9%. Please convert that to a decimal correctly. 0.09, don't lose the 0 in front of the 9. And then new is just X, and so this is one of the more straightforward problems. Where you take 9% of 450,000 and add. And so what does that wind up being? 490,500. And again, I might get pissy and take a point off if I left it like that. What should I really say? People, right? Do not lose silly points for not labeling your numbers, okay, folks? I mean, 1 point isn't that big a deal, but if you do it 4 or 5 times, then it starts to add up, and then it becomes a big deal. Don't let that happen. All right, again, though, being careful. Oh, I love this next question. This is right off the final from 3 years ago. It's really hard sometimes to read these questions and not let your gut answer the problem. What does your gut want to tell you to do with this problem? We really, really, really want to take 360 and just take half of it, right? I mean, we really do, right? And half of 360 is $180, right? What's half of $180, folks? 90. What's $180 plus $90? 270. Is it 360? You know $180 is wrong. Do not let your gut do math, okay? If you are only marginally good at doing math, I guarantee you that your gut blatantly sucks, okay? That's all there is to it, all right? If you're good at math, you can sometimes do it with your gut and get away with it, right? But if you're shaky already, then trying to use your gut is always going to be wrong. You should really almost do the opposite of what your gut tells you. So, the key to this one, folks, is taking it slow. This is a percentage increase problem, right? So, the fact that you're taking half of this, that means that you're subtracting, right? What do you never do in a percentage increase problem? Subtract. So this is definitely going to not be half of 360. So how do we get there then? What is the $360?
The new.
That's the new, right? It is not the old. Rate's 50%, and you guys can go straight to 0.5. You don't need to write the 50% out. That was pretty obvious. And in this case, the old is what's missing, and it's our x. And so now we can take these values, put them into the formula that we had, and say, great, 360 equals x plus 0.5x. What is x plus 0.5x? 1.5 x's. What are we going to do to get x by itself? Divide by the 1.5. And here's how you get smaller numbers without subtracting, folks. Dividing by a number that's more than 1. All right? And so what is our ultimate answer? And does that make sense? Because what's half of 240? 120. What's 240 plus 120? 360. Okay? When the numbers are easy, it is also easy to check. Okay? So if you accidentally try and say 180, if you stop and think about it even for a little bit, what's half of 180? 90. Oh crap. It doesn't add up. Okay? Alright, so just again, please be careful with that one. Alright. Price of my shirt fell from $44 down to $19.99. What was the percent discount? How are we going to do this one, folks?
It'll be a decrease.
Hmm? This is a decrease problem, right? Discounts with decreases. What's new and what's old?
1999 is new.
The rate is X this time, folks. How do you solve for X in this equation? Subtract the 44 first. Please be careful with that one. I get a lot of people who try and divide by 44 right off the bat. That doesn't work. Oh, what is that? 24, negative 24 over 1?
square.
And so what do we do to get x by itself here at the end? And nicely enough, the negatives cancel, so we don't wind with any sort of negative number. What is x equal to? Somebody punch that out for me. That represents the decimal representation. So what do I do first? Make it a percent first. So it's 54.772222%. And what did the problem tell us to do?
It's actually 72727.
Oh, it's 7272? That makes more sense. And so what does it round to then? That makes a bit of a difference, obviously. 54.73%. Note, please, please, pretty please, do not just take 1999 and divide by 44. If you take 1999 and divide by 44, you're going to get 45.27%.
You can do the short.
Yes, you can do the shortcut. So, Chloe, how would I do the shortcut? So let's do the next problem using the shortcut.
So the original is on the bottom, so the 1999.
Is on the bottom?
Yeah.
Yes. Uh-huh.
44 is on the top.
Well, what do I put on the top? The difference, right?
Yeah.
So the shortcut, remember that the shortcut equals the difference, if I could spell the word, divided by where you started, right? And since this is a percentage increase, we started at 1999 and hopped up to 44, you can just subtract the numbers and divide, right? $24.01 divided by 1999. What do you get when you do that division? And what do I have to do with it again? Make it a percent because this is the decimal representation. 1, 2. And what did I say to round it to this time? Hundredths again? Okay. $120.11%. And again, folks, you should, when you do your percentage problems, make sure that you take a quick glance and make sure that the number makes sense, right? If the price of an item went up 120.11%, that basically means it has to more than double, right? Going up 100% means double the price. It was 20, double 20 is 40. That's 44 is more than that. That means it went up more than 100%. That number makes sense. All right? It's also similar to the problem up above it, right? If the price used to be 44 and is now $19.99, and it went down 54%, that means it had to go down by more than half. Half of 44 is 22. $19.99 is more than going down by half. More than 50% makes sense. Okay? Definitely look for simple things like that to check your answer just to be safe. Okay? And again, folks, I'm happy either way you do these problems. If you do them using the algebra, great. It's great practice. I strongly encourage it. If you want to just use the shortcut and get to the answer faster, I am okay with that. All right. How about my pay cut? What kind of problem is this? Because it was an 8.2% pay cut, right? Sigh. What did I give you this time, new or old?
Old.
Old, because I was making the $72,000, and I'm asking what do I make now, therefore it's new. And so this is one of the more traditional problems. Just be careful converting the 8.2% into 0.082. Ugh. What did I fall down to after taking my 8.2% pay cut? What was that?
71,409.60. That makes sense.
I know 66.
92?
Oh, 96, sorry.
96. That sounds about right. 72 times 2 is a 4, so when you subtract, you want to put the 6. What'd you do, Greg?
Oh, I see it.
Okay.
Never mind. I got it.
Alright. That's okay. Now I like this last problem, and I like it on many levels. One, because it's tricky, and I like tricky. And two, because I like it when my salary is really big too.
I thought you were going to say you like it when you get pay cuts.
Well, I'm a teacher, so yes, I should like it when I get paid. That's the only thing I've gotten in the last 5 years working here. Alright, so this problem is a little bit tricky, right? Because what does the very first sentence tell us? I'm getting a pay cut, right? And so your gut says this is a percentage decrease problem. But what is there a percent value in that first sentence that goes with the word pay cut? No, right? All it told me was what the dollar amount of my pay cut was. What does the next sentence say? It was 1.4% of my salary. It didn't say it was 1.4% less, 1.4% more. It was just telling you that it is 1.4% of my salary. This is actually a straight portion equals base times rate problem. Okay? And it's purely because the percent sign only has the word of my salary after it. And it's not saying 1.4% more of it or 1.4% less of it. It's just saying that this number is 1.4% of my salary. And then you have to deal with the pay cut yourself after you figure out all the numbers. Okay? So, my R is 1.4%. Again, make sure you convert it to a rate properly, 0.014. Now, the $3,500, folks, is that my portion or my base? Portion, right? Because that is the portion of my salary that they are cutting, right? If my actual salary was $3,500, I would not be doing this job. Because I wouldn't be able to drive the 60 or 70 miles to get here every day because I wouldn't be able to afford the gas, right? So therefore the base, my actual salary, I don't know, right? So, going into PDR, 3,500 equals 0.014x. Or if you want, folks, you can do is over of. Remember that portion is always is, base is always of. If you went 3,500 over x equals 1.4 over 100, this is the exact same method for solving this, okay? So whenever you have portion equals base times rate, you can think of it as is over of, just make the portion is and the base of, okay? So technically, working off the portion equals base times rate portion, folks, what I would do is divide by 0.014. was that?
250,000.
I don't mind that.
What does that number represent?
Your old salary.
This is my old salary. So what's my new salary after I had to take this terrible pay cut? I mean, come on, it's terrible, right? Minus $3,500. I'm going to be broke after this, right? Because now I'm only making $236,500 is my new salary.
I quit.
If I'm not making at least $250,000, there's no way I'm doing this job. Again, folks, the key to that problem is looking at the words around the percent sign, okay? And realizing that the percent sign is only working with the of, and that's going to drive you to the old salary, and then you have to use logic to say, oh, where does my new salary come from? I subtract the pay cut from the old. All right? There's definitely a homework problem or two like this as well, where they give you the percent increase or the percent decrease amount, and you kind of have to figure things out from there. All right? All right. So that's our review. Any questions on the homework in Chapter 6? Standard 3, as you see fit. Deal with the giggling girls. What was that, Monroe?
Oh, number 78.
Number 78. All right, what does number 78 say?
Number of mortgage applications declined by 7%.
Oh, hang on. Declined by 7%.
Yes.
Okay. Keep going.
That was 1,600,025,418.
Read that number to me again.
I'm sorry, I'm just gonna read it straightforward.
Okay.
1,625,415.
Okay.
What had been the previous year's number of applications? Okay, back to you.
What was previous year's number? All right, so what kind of problem is this, folks? Percent decrease. So again, what you will be trying to do is trying to say, oh, the new is equal to the old minus the rate times the old. Please remember that you get a note card for the next test, folks. Strongly encourage potentially writing these down just to remind yourself and to be safe. Now, what have I given you in this problem? The new, right? Because it declined this year to 7%, by 7% to this number, and we want to know what was it last year. So I didn't give you the old, I gave you the new, 1,625,415 people. And the rate, 7%, again, convert to a decimal correctly. And so then our old is X, we don't know. And now you can do some algebra, right? Of course, the numbers are annoying, right? 1,625,415 equals X minus 0.07X. Now that you guys have seen it a few times, what is X minus 0.07X?
Agreed.
All right.
Don't expect me to answer that all the time.
Oh, I'm going to. And so then how do we get up to our earlier value? divide by the 0.93. Now, folks, what does this number represent? What's its label? What are we describing? People, right? Applications?
It's not people, it's
Applications
applications.
are people. There's a one-to-one correspondence to every
How about
application.
applicants?
Applicant, okay. That's a person.
See, it's
Unless
that
you're
way
letting-
sound-
unless
that
you're
way
letting-
sounds better.
Unless you're letting dogs apply to some of the jobs here, right? Then maybe it's not, right? Regardless, though, since it's people or applicants, round to the nearest whole number because it doesn't make sense to have, 5/10 of an application, right? Or whatever. So when you take 1,625,415 divided by 0.93, what do we wind up getting?
1,747,758.
758. And applicants.
People.
Or people, which is what I would like to say, but we can say applicants if we want to sound snootier than their average person. Right. Both cool. So I must slide into your slightly British accent and sip your tea with your pinky up. And you have to have crumpets with it too, because those are good. That was probably the best thing I ate when I was in England, was the little cookies that came with the tea. Everything else was awful. Yeah, it was mildly depressing. Then, of course, we went to France right afterwards. It's like, oh, okay. That's how you eat, folks. You eat in France and you drink in England. That's sort of general rule of thumb. All right, so again, being careful, folks. This is one of those where I gave you the new and you have to go back to find the old. All right? Another one? Look. 50. All right, what does 50 say?
So it says product is Apple iPad, and the selling price for 2013 was
Whoa, okay, so we're selling it for
2013 was 650, 2014 was 500.
So in 2013, sorry, what was the number again?
650,
650. And in 2014?
500.
Okay. And what are we supposed to do with that?
The next column is amount of decrease or increase,
Amount of decrease, okay.
and then the next column is percent change to nearest 100% as needed.
Okay, so percent change and round to hundredths of a percent, right? Okay, so how much did the iPad price change?
150.
Okay, good. So if you're trying to figure out how much the amount that it has changed, you say $150. Awesome. And note, folks, that's the difference. How do you use the shortcut to figure out what a percentage change is? Percentage change equals the difference divided by where we started. And you just figured out the difference, $150. All you have to do is tell me, where did we start? 650. What's 15 over 65?
100%.
Give me a bunch of decimal points. Remember, that's the decimal representation. What do I have to do first? Make it a percentage. And then what did the problem ask us to do? Round to the hundredths. What does it round to in the hundredths place?
108.
23.08%. So please be careful rounding your percentages to the correct place marker. Most of the times the problems say round it to the nearest hundredth of a percent, but there's a couple in there that ask you to do it to the tenth, so just make sure you read the directions about where to round at the end, okay? Okay. One more? $92. is fun. Alright, so what does 92 say? Somebody read 92 to me, please.
A major airline laid off 4,000 pilots and flight attendants.
Okay, thank you. Stop for that. Laid off 4,000 people. Okay, cool.
12.5% reduction in workforce.
This is a 12.5% reduction of staff. Okay?
How many people after layoffs?
How many people after the layoff?
It's just like the last one we did.
Yes, this is exactly like the problem I gave you on the review, right? They laid off 4,000 people. This is 12.5% of the staff. So it's going to reduce the staff by 12.5%. The key, though, is that this technically is that kind of a problem. It's tricky because it's worded in business speak. Business speak tries to write things so that it sounds confusing. Welcome to life to some degree. All right? But the 4,000 people is 12.5% of the staff. So you need to figure out how much of the staff were there first. The portion is the 4,000 people that you laid off. The base you don't know. And the rate's the 12.5%. 125. And again, if you want to do this as is over of, think of P as being is and B as being of. For me, I'm going to say 4,000 equals 0.125x and solve for x to show me where I was at the beginning, right, before the layoffs. Take 4,000, divide by 0.125. There were 32,000 people originally. So is that the answer to the question? No, because what did I ask for? After the 4,000 layoffs, right? So this is original number of staff. And so to get after the layoffs, subtract your 4,000 people layoff. You are down to 28,000 people after you have laid off the 4,000 employees. And that is very much so a position that most businesses are trying to do right now, reduce workforce, right? They want to hire lots of people, but at the same time they want to lay them off just as much as they possibly can and replace them with machines because machines are cheaper. They don't need health care. Or their health care is cheap. You can just, outsource the IT people to come in and fix the machine whenever it breaks, what have you.
How is a flight attendant supposed to be built?
It won't take long, right? It'll just be a person that they put on a track wheel. They'll run it down the aisle, and you can pick your drink up off the tray.
I mean, really, you don't even need them. They can make you just
They
sit
can't
on a
get
flight
people with
without.
volunteers. That's not good.
Yeah, the only thing that the flight attendants are actually serving as a purpose for the flights now is if there's a problem, right? I mean, if there's an issue, you need to be able to talk to a person, and obviously you can't go
Isn't
and
that
talk
why
to
there's
the
a
pilot.
marshal role?
What?
Isn't that why there's an air marshal role?
Well, yeah, but it was one air marshal going to be able to handle a plane crash when 600 people on the plane are freaking out? No, so you get 4 or 5 extra flight attendants to do it. Yeah, I'm sure that the airline companies are looking for a way to replace them. Wouldn't surprise me if it happens sometime soon. I mean, it's happening all over the place on other service jobs, right? When you go to the grocery store, you don't run through the checkout counter anymore, you self-check, right? When you go to a fast food joint, you punch in what you want on a screen instead of talking to a person, same thing. It's just a matter of time. All right, so that is Chapter 6, folks. If you are happy with your Chapter 6 homework, I would love it if you turned it in. You obviously do not need to because I know it's a long assignment. So if you want to wait until Tuesday next week, that is fine with me. All righty? All right, so new stuff.
Yeah.
No,
I forgot.
I got another 10 minutes at least. I never leave early. You guys paid way too much money for this class for me to leave early. I'm sure you'd feel cheated out of, some of your money if I left early. So I'll never do that to you. All right. So, Chapter 7 is talking about the discount process in business. Now, the key to working in Chapter 7, folks, is that you have to kind of change your way of thinking when you think about the discount process in business. Because we're not talking about discounting in terms of you got a 25% discount when you go to Kohl's. This is more along the lines of what does Kohl's get as a discount when it buys from its suppliers and those suppliers ship the goods to them and they are trying to sell it. Okay? So our job in this chapter is think like a business owner. Alright? So you got to kind of take your brain and pull it out of your ear for a little while, wash it into some soapy warm water and say, look, I am not a buyer of a product anymore. What I am is really the seller of a product. And what I need to do is get that product from someone else at a cheap price and then sell it for more than that. Okay? Now, that's the generic business process. Okay? The best way to think about this is to think about it in terms of how does a retail business run, okay? Because that's really the way that we're describing this discount process, is the way that retail businesses set up their business model. Now, so first thing we have to do, and it's always a good thing to start this way, is with terminology, okay? So again, think of yourself as being a retail shop. So imagine, if you will, that you open up some, trinket shop in the mall, like even those little carts in the middle of the mall where they're selling Christmas ornaments, like little kiosk things, right? I mean, that's sort of the new wave of selling things, is that you see a demand out there in the real world, and then you all of a sudden create a kiosk and start selling it. So those little finger spinners that came out in the world, 3 or 4 years ago? Yeah, I mean, those were like a humongous deal for 6 months, right? The biggest problem that the large department stores had was that they didn't have a quick way of responding to demand, right? But all of those little kiosk owners, they were like, sweet, no problem. I got 2 guys that I know who have a factory who are making this crap, and that it costs them 25 cents to make it. You'll tell them, hey, look, I'll buy them off you for $2 and then sell them for 10. They're making a profit, right? Because it costs them 25 cents to make it. You're buying it off of them for 2, and you're selling it for 10. You're making 8. You're going, sweet. Walk me to the bank, right? But that's the idea, all right? Now, terminology that you need to be comfortable with, because I will ask the questions using this terminology. Okay, folks? I really am going to use the standard business speak behind all of this. So you need to know what the words are that go with the math, right? And the math is not going to be overly complicated, but if you don't know the words, you're not going to know what math goes with what, okay? So, first off, when you're working in the retail business, folks, list price. The list price for a retail business, the other terminology that's often used, is the suggested retail price, or probably what you guys have heard is MSRP, the manufacturer's suggested retail price. Whenever you hear that phrase MSRP, you know you are dealing with someone who is a retail shop owner. Because MSRP is the manufacturer telling the seller, dude, this is what you sell at. Okay? So list price is what you sell your items for. This is the price that we, as business owners, sell our product for. Okay? So the list price is what we are selling at, and it's really dictated by the supplier, not necessarily by us in the retail shop business. Okay? Someone else is doing the research to determine what should you try and sell this for. All right? Now, this is what we're going to sell it for, folks. How much are we going to pay for this? Are we going to pay the list price? No, because if you pay the same price for something that you sell it for, how much profit have you made? None. And how long will your business stay open if your profit is always zero? Not long. Okay, so what we need is another price that represents what you actually pay for it. The actual price is the retail price. Okay? And again, it sounds like stuff that you've heard before, and it really is. This is exactly what it's going on, right? But in the business world, it's really called the net price, okay? So you can think of it in terms of being the retail price, but the appropriate term that we use in the business world is net price. Because there's actually going to be a calculation that we use to determine what the net price is, okay? So net price is what we actually pay. Actually, there's an A in there. Actually pay for the product that we are selling. Okay, so again, it sounds like it's a little backwards, and it is a little bit to some degree. But list price, net price. List price is what we're selling it for. Net price is what we're paying for it. And then the last term that will sort of round out the simple equation that drives the relationship between these two is the trade discount amount. And the trade discount amount is just the difference between list and net. Difference between list and net price. But again, since it's called a discount, folks, the way it's often described is for the amount discounted on the list price to get us to net price. It's the same thing. It's just saying it in more of a business speak terminology. Because since this is a discount, what it really is the number that you subtract from the list to get the net. All right? So the really, really, really scary math equation that we have for our three terms here, right? So we've got three terms: list price, net price, and trade discount amount.
So if, like, say, like, we bought something at net price, isn't that, like, wholesale?
Yeah, that's like wholesale. In theory, again, realize that whenever you buy anything for wholesale, you're never buying it for wholesale. You're buying it as the advertised wholesale, which is never the same. If you will talk about that in your business classes when you get there. The sneaky things that businesses do to tell you that they're selling at wholesale, but they're really not, right? I mean, that's the biggest load of enough said, right? Because if they were selling it for their wholesale price, that means they're selling it for the same price they paid for it. That means they're making no profit. No. No business does that, folks. Unless that business is trying to kill their competition, they do not do that. All right? That's just flat out wrong. All right, so anyways, the big math equation. Here's the big ta-da, right? Ta-da! You're not all going ooh ah, because it's not all that exciting, is it? Because the math is not really complicated, right? The net price equals the list price minus the trade discount amount. That's how it works. All right. Now, let's put this back into business terms again so that we can sort of see this in a business term calculation. What is the net price again in business? Right? What we pay for it. What's the list price? It's what we sell it for. What is the trade discount amount? What's the difference between what we paid and what we sell? Profit. All right. So what number in here do we care the most about? Yeah. And note, folks, that that's honestly the way retail businesses work. They don't work off of what the selling price is, okay? They actually don't worry about it. That's someone else's job. That's the wholesaler. That's the manufacturer's job to tell them, hey, sell this car for $22,000. All right? Their job is to say, okay, I'm going to sell it for $22,000. I want to pay you, the manufacturer, as little as I can, so that when I sell it for $22,000, I make the most profit possible. All right? That's your job as a retail business, is to negotiate with your manufacturer. That's the only thing you do. All right? Because you don't set the price, someone else is doing that. Okay? And you don't want to lower the price, because most of the times you've signed a contract with your manufacturer that says you won't do that. Right? Because if you lower the price, what ends up happening? You sell more, right? Which you think is good, but the problem then is that the manufacturer then has to produce more. If they're not setting their production up to produce more, can they produce more so that you can sell it? No. And so what happens is you sit around trying to sell something that you don't have, and guess what? You can't. That's the way it works. All right? So the whole idea here is that both the manufacturer and the retailer are controlling the supply of product in the system. And they're purposely keeping the price higher so that both of them can make more profit in the deal. All right? That's their goal. They don't want to sell more, because if they sell more, they have to lower the price. And that's not going to make either of the businesses happy. Right? It'll make you guys happy, but honestly, folks, I'm sorry, but businesses really don't give a shit about their customers. They care about your money, but they do not care about you. Anybody that says that they do, yeah, they're just trying to get more money. Okay? That's all they're trying to do. Now, there is one more thing that we have to do before I'm going to call it a day, and that's, how do you go about getting this trade discount amount? Where does it come from? Well, folks, remember that I said everything in these next few chapters is always about percentages? What's missing up here? A percentage. So what do we need to do? We need to get a discount rate, right? So the trade discount amount will be negotiated as a percentage of the list price. That's the way they do it. Trade discount rate times the list price. So your discount amount will always be a percentage of whatever the list price is. And honestly, folks, this is the only thing that you negotiate with your manufacturer, is what's my trade discount percentage. Right? And if you can convince them to give you a higher percentage discount, you make more money. If you can't, then you don't. Period. All right? And just so that you can see it before we go, I take what this trade discount amount is as a calculation and substitute it up into that equation. Net price equals list price minus trade discount rate times list price. What does that look like?
Correctly. Second one.
Well, what were we doing just a second ago, folks? New, this is old minus rate times old. This, folks, is just a percentage difference. That's all it is, okay? And so what we are going to do is come back on Tuesday next week and talk about how you go about building up this relationship and how you deal with invoices where you've got some certain trade discount amount, etc., etc., etc. All right? So, again, please make sure you get the Chapter 6 homework done, and then we will finish up Chapter 7 next week.